Good morning.
Yes, so in this session, we'll start with the new module, which is SQL, not machine learning. Because some of you, there are three new students, they are not aware about anything related to Python, right? So it's not good idea to get started with the machine learning part. Instead of that, we'll start with that module, which does not require any prerequisite knowledge for Python or statistics or any such kind of thing, programming language, right? So we'll start with SQL instead of your machine learning part. So I'll quickly share my screen. And yeah, alright. So let us divide this section into different parts. First module is database design. Let us consider first module as database design. So far, you have learned how to perform basic data analysis using Python and Excel. Excel we have not started, but so far we have learned how to perform basic data analysis using Python, right? Now you also have learned that it is risky to manage data from different files and that it may lead to inconsistencies. Any organization cannot track its business activities efficiently by maintaining a large number of files. So I'll write down over here, any organizations cannot track its business activities efficiently by maintaining a large number of files. Hence, database is needed. Hence, database are used for accessing and managing data efficiently. Software known as DBMS, Database Management System, DBMS is used widely in the industry. In the industry to analyze data easily. To analyze data easily, right? So you will be introduced to the concepts of data warehouse, star schema, OLAP, which is online analytical processing, then OLTP, online transactional processing, online transactional processing, SETL. which is select, extract, selection, extraction, transformation, and loading. And what do we mean by constraints? What is ERD? Entity relationship diagram. Entity relationship diagrams. Right? Alright. So let us go to next part. So coming towards the question, what is a data warehouse?
सर,
Yes.
जो अभी बताया ना ये ओ टी एल पी, वो एक्चुअली है क्या?
Hmm?
वो स्टार स्कीमा, ओ एल ए पी, ओ टी एल पी या सी
Hmm.
टी एल, वो एक्चुअली है क्या? यूज?
वो सीखने वाले ना, वही तो बोल रहा हूँ मैं. वी आर गोइंग टू स्टडी दिस कॉन्सेप्ट्स वन बाय वन.
हाँ, मतलब है क्या है? और
तो वही अभी डेटा वेयरहाउस सीख रहे हैं ना.
ठीक
One by one we'll learn this. First we'll understand what is data warehouse. Then I'll explain you what is star schema. So this is the first topic that we have started just now. Right? उसके बाद में अपन स्टार स्कीमा देखेंगे, फिर OLAP देखेंगे, then OTLP देखेंगे. It's not like I have covered this. I have just started. I have just given introduction कि we are going to study this. Right?
ओके.
Now what is a data warehouse? What is a data
द
warehouse?
लोकेशन
The place where data is stored.
स्टोर.
All right. So think of yourself as a data analyst working for a company that has the following three departments. That has the following three departments. Departments are marketing, sales, finance. Now let us assume that each department maintains its separate database. So each department has a separate database. This could lead to a situation wherein each department has its own version of facts. For a question such as what is the total revenue of the last quarter, or every department might have a different answer for this. This is because each department draws information from different database, right? Each department draws information from a different database. So this is where a data warehouse can prove to be useful. It can help with creating a single version of the truth and facts. A data warehouse would thus be the central repository of data of the entire enterprise. So it works as central repository of data of the excuse me, entire enterprise. Now let us watch, let us understand the concepts of data warehouse. What is a definition of data warehouse? How it is useful for companies in carrying out data analytics. And you also learn about OLAP, which stands for Online Analytical Processing. So what is OLAP? OLAP is nothing but it is used to extract business relevant information and perform. Uh, OLAP is used to extract business relevant information and perform analysis on the data stored in data warehouse. So let us understand this. Imagine uh, you're working in an organization. Just a minute. Just a minute. Okay. So yeah. So usually data needs to be in a format which makes it easier to find answers to business problems, right? It has to be meaningful business to be meaningfully use these tools such as SQL, W for data analysis. And for that, data needs to be in a format which makes it easier to find answers to your business problems. But usually, data is scanned across various departments and local data repository. So how do you meaningfully analyze the data of millions of users and products spread over multiple data sources? Suppose you have various departments in your organization and local data repository. So how do you meaningfully analyze the data of millions of users? How do you meaningfully analyze the data of millions of users and products spread over multiple data sources? So this is where data warehousing and business intelligence comes into the picture. In this in this session, we'll look at an important technique called as online analytical processing. In short, there are two important technologies that play a role in the implementation of OLAP: the data warehouse in the back end and business intelligence in the front end. I'm going to begin by talking about data warehouse. Indeed, there is a lot of engaging discussion surrounding what is data warehouse, how it is different from a regular database we use on a day-to-day basis for booking our tickets, placing orders in the stock market, and so on. So information lying in various systems across the back, can I simply keep it in everywhere around the house? No, right? It becomes important for me to keep it in one place so that it becomes easier for me to access. In a typical bank, for example, you have 200 or 300 different applications. Let's take a bank example. Let's say you have 200 to 300 typical applications, and every application touches customer. Can I get all this data into single environment or single place? Becomes a rather requirement for me. So data warehouse is a technique or way in which you organize all this data from different sources. So now you know the basics of what data warehouse is. It is basically a central repository of the data from various sources. But is that all I imagine? Suppose you are in an interview and ask the question, what is data warehouse? What will be your answer? So there's one guy whose name is Bill Inman. He has given a second definition of what data warehouse is. So he told that data warehouse is, it is a subject oriented, integrated repository, non volatile, and time variant collection of data in support of management decision. Now I would now draw your attention to this four pillars of data warehouse, which we can call it as the definition of data warehouse. So We'll discuss each one in depth. Firstly, a data warehouse is a subject oriented in nature. What we mean is that the data warehouse includes the collection of data pertaining to a handful of well defined subjects rather than including the whole gamut of information on the entire enterprise. Just look at this. Just look at this way we have assembled the data sets for investment analysis. So let us understand the first pillar, which is subject oriented. Subject oriented. So we have collected information about the startup companies. Let us take an example that we are going to do the investment analysis. We have collected an information about the startup companies in the company data file and information about the investment made in the investment data file. Just for illustration, let us look at a couple of examples to see when you would not consider this to be a data warehouse. Suppose we collected all this information from online portal like nascom.com, nascom.com, right? Where startup can log in and upload their information applying for funding. If my dataset included all their application details, such as the buyer data, of all employees information about their past product and so on, then clearly our data store contains information about many subjects according to Bill Inmon, that it is not a good thing for analysis instead, right? Since we are interested in sector-wise and geo-wise analysis of our investment, we should include only data pertaining to these subjects in our data warehouse. So it has to be only, it should not be entire confusion, or it should not be, data warehouse should not have n number of components which are not required. It should only have the necessary components of the analysis, right? So it does not make any sense that we should add name of the investor, his background, his educational details. It's not needed over there, right? What is needed over there is we only want investor, let's say investor country code. We only want uh, investor state code. We only want investor city, and we only want funded at date and raised amount. It does not make any sense to add investor city details, investor company address, or company employees, total number of employees, something like that. For an example, I can have this country codes: Hong Kong, let's say USA, and USA. Investor state code, I do have state code. Let us give some random state codes: PA or CA. Investor city, let's say Shanghai, Frankfurt, Hong Kong, MCLEN, and Menlo Park. Funded at 1903 08 24 07 14 01 07 14 09 11 15 and 22 05 13. And raise amount is, let's say, $2 million or something like that, $40,000, $41,000 to $50, $3 million, something like that, right? So since we are interested only sector-wise and geo-wise analysis of our investment, we should only include the data pertaining to the subjects in our data warehouse. Now let us move uh, to the next definition, second keyword, which is integrate. So second keyword is integrated repository. What do you mean by that? Data warehouse is an integrated repository. Integrated repository. It is worth noting that information pertaining to a subject may actually be coming from many different systems. In our own case, there could be one portal where the startup application data is collected. There might be another database that contains industry sector or industry standard sector information. There might be yet another database that contains information about the investor themselves. So what we are saying is that when building a data warehouse, we must bring together all the information from these multiple sources into a single integrated data warehouse repository hosted in a single location over there. So you might have uh, one portal where startup application data is collected. There might be another database which contains industry standard sector, and there might be another database which contains information about the investor themselves. So what we are saying is that when building a data warehouse, we must bring together all the information from these multiple sources into a single integrated data warehouse repository hosted in a single location. The third definition is, moving on, the third keyword in the definition of data warehouse is that data warehouse is a non-volatile in nature. Volatility indicates changes in the context of data warehouse. What we want to say is that data warehouse is a repository that will never change this part of the definition. It gains enormous significance in the face of stringent compliance standards like, so we call it that have surfaced to prevent fraudulent activities. So needless to say that non-volatility also prevents the data from being erased or deleted. What do you mean by non-volatility? Suppose if I have this data, so I cannot remove this data once it is created. That means non-volatility. So it allows us non-volatility. I am correct over here. Huh. So it also prevents data from being erased or deleted. It prevents data from being erased or deleted. The non-volatile nature of a data warehouse is important for giving legitimacy and credibility to the analysis being done on the data in the context of our investment analysis. What we are saying is that we cannot keep modifying the figures of exact investment that have been made by a given investor. If that is allowed, our whole analysis will become questionable, right? That brings up the seemingly contradicting requirement that the data warehouse is a time variant. We cannot keep modifying the figures. Suppose if this investor has invested this amount, we cannot keep modifying. Let's say on 19th of March 2008, this investor has invested this amount, right? But if I want to, let's say same investor I have, and he has invested another, let's say 2004 2020, another $20,000. So we cannot go here and we cannot modify this, right? We have to add another column that becomes this database volatile, right? So there can be same investor, but data should not be edited. So if that is allowed, our whole analysis will become questionable. That brings up the seemingly contradicting requirements that the data warehouse is a time variant. Here, time variance is the fourth keyword for the definition. It is referring to the importance of historical data for analysis. The time variant nature of data helps us build adaptive analytics that reflects newer understanding and inferences based on newer data. I would like to add that time variance does not contradict with non-volatility requirement, or non-volatility only prevents existing data from being changed without any legitimate reason. But there is a problem with newer data being added to build historical information. Just think about it. In our investment data, we have an investor called DT Capital, let's say, or we have an investor DU, this investor, second. So he has invested $40,000 in something like 06.com, and we are not allowed to fudge that number or change it. So that is non-volatility for you. On the other hand, if the same investor had invested in the same company for some other, let's say sometime later, let's say this investor, and same investor has invested in the same company for after some time later, we are allowed to add the data to build historical information about that investor. So there you have it, a full definition of data warehouse. We saw the four important keywords from the definition: subject oriented, integrated repository, non-volatility, and time variance. Now, data warehouses are important for organization because if you have to do the analysis of the data from an enterprise view, if you're looking at an enterprise view, you have to work with all the systems in the enterprise, right? So if I'm the CEO or CFO of the organization, I need to look at my organization in its totality. Then what will happen as I will have to, or I will have multiple system talking to me. I will have the sales system in my organization. I will have an HR system talking to me. I will have uh, something like marketing, the risk system, a risk department. All of them have their own system and processes. Now I don't get one view. If I were to given out this task to somebody to create that one view, they would have to go and understand all this department, all these systems. So they would have to understand the appropriate linkage between the systems, and they would have to create that view. So all of this is solved by your database, data warehouse. So that's why data warehouse is needed, right? So if somebody asks you in an interview what is data warehouse, you should tell this thing, and you can obviously explain this example to explain this particular point, which is data warehouse. Is it clear now, everyone? What is a data warehouse?
Yes.
Now let us go to next part. Let us understand the structure of a data warehouse. So having said that, we only have discussed the what do you mean by data warehouse. Now let us understand what is your structure of a data warehouse. So you go through this point one more time. I'll take a 5 minutes break. You go through this, and if you have any questions, you can ask. So it's 9:17. I'll be back in 5 minutes. We'll see what do we mean by structure of a data warehouse. All right. So the next is structure of a data warehouse. So there are two key elements of dimensional modeling. It includes facts and dimension, or one of the primary methods of designing a data warehouse is known as dimensional modeling. So in the previous session, we have talked about concept of data warehouse. Now, one of the primary methods of designing a data warehouse is known as your dimensional modeling. So designing a data warehouse is nothing but it is known as dimensional modeling. So there are two key elements of a dimensional modeling. It includes facts and it includes dimensions, which are basically the different types of variable that are used to design a data warehouse. They are arranged in a specific manner and it is known as a schema diagram. So what do you mean by schema diagram? You are going to arrange facts and dimension in a specific manner. So uh, yeah. So imagine you are working as an in an organization such as Flipkart or Amazon and asked to identify the products. You're asked to identify the products in the electronic segment that are non-profitable in the electronic segment that are non-profitable in the rural Uttar Pradesh, right? And you have to test if this is due to high cost of transportation. You have access to sales database. You have access to their sales database from various districts or various product information. Various product information or various order information, which includes the means of transport used in customer management system database and many other such databases. How will you proceed? This session will uh, teach you exactly what you should answer to do to answer such a question before data can be loaded in the data warehouse. We first need to create appropriate structures for storing the data. By structures, we mean what should be the tables, what should be the columns, or what should be the data types, and so on. So this process is called design of a data warehouse. We'll look now will now talk about a specific design techniques. This technique is called dimensional modeling. The two key elements of dimensional modeling are dimensions and facts. So let us talk about the facts first. What do we mean by fact is a numeric data. Fact is a numeric data that we want to analyze, right? So fact in general, numeric attribute are called as fact variables. And in our investment data file, the investment amount is an example of a fact variable. So let us take this example. In our investment, this thing, the investment amount is your fact variable. Suppose you have this database, the amount raised is your fact variable. Now you can look into our company data file and identify a fact variable. So funding, which is total USD dollar or US dollar, is a fact variable in the company file. There are several fact variables and corresponding fact make a fact table. So I hope you are with me now till this time. Now let us talk about the dimension variable. Dimension variable adds life to the fact variable. What I mean by that is dimensions can be used as basis for analyzing the fact data. In the sector list, for an example, sector list is an example of dimension variable. So कौन से sector में है investor? Let's say marketing sector or production sector, something like that, right? So it's an example of dimension variable. Dimension variable. So it adds life to the fact variable. Or company being funded, or even funding agency information is an example of your dimension variable. Now you can see that without these dimensions, or without these dimension variables, the fact variable are meaningless. And what analysis can you do with big bunch of numbers without having an additional information about those numbers? So that is why dimension variable can be thought of as metadata corresponding metadata corresponding to the fact corresponding to the fact variable. Several dimension attributes, for example, company, permanent link, name, sector, list, their country code, state code, region, city, along with their all the values, make up your dimension table. Now, what it means is the analyst can choose any of this attribute to initiate the analysis. I may want to analyze the investment on the basis of sector. Let's say you want to analyze the investment on the basis of sector, of state code, or even city, right? So that's where your dimension comes into the picture. So there can be n number of examples for dimension as we have discussed. We can have uh, company name, we can have their sector, we can have country code, we can have state code, we can have region, we can have city, right? This summarizes your dimension variable. Yeah, so what we are talking about is we are talking about the structure of a data warehouse. Now let us understand the difference between OLAP and OLTP. So what is OLAP? What is OLTP? So I know there is always this vexing question about the difference between a data warehouse and a database. To begin with, I'll tell you that that's a wrong question at all. To ask a question or to ask a reason, the database is nothing but a collection of data, right? So the data warehouse is also a collection of data. The more proper or more appropriate question to ask would be difference between data warehouse and transactional database. It's not correct question that difference between data warehouse and database. It's not a correct question. Correct question is data warehouse and database. Now let me define this term called transactional database. Let me define this term called transactional database for you by taking the example of e-commerce. For an example, Flipkart or Amazon's. So the normal purchase that you do on the website, right? So you log in, you search for your product, you add it to the cart, and then you connect to the payment system, and then you make your payments, enter the OTP, right? The whole thing requires some kind of a database, isn't it? So that database is called as transactional database. So in a very simple words, transactional database is a database where the transactions are happening, right? Or just before to this, we can add one more sheet to just understand the uh, star schema, which we have not discussed. So let us discuss that before proceeding further with the difference between data warehouse and transactional database. Let's add star schema. So what is the star schema? In the previous segment, you learn about the facts and dimensions, which are the two key elements of dimensional modeling. Now, a typical problem might involve multiple database with many different variables, but we may not be interested in all of them, right? Hence, only some facts and dimension are combined in a specific manner to build the structure of a data warehouse called a schema diagram. A schema is an outline of the entire data warehouse. It shows how different data sets are connected and how the different attributes of each data set are used for a data warehouse. So, what is a star schema? It is a connection between your facts and dimensions. So, if I just add star schema, it's just a collection of your fact and dimension. So, for an example, let us take this figure. Let us take this, in which we have, let's say this is our star schema. So, remember in star schema, your central table is always and always a fact table, as you can see in the figure as well. It is surrounded by fact table is surrounded by your dimensions, right? So we have this fact table. Fact table can always and always be your numeric column, right? Product ID, time, promotion ID, customer ID, revenue, units sold. These are the numeric columns, and these are the dimensions for that fact variable. So we have product dimension, we have customer dimension, fact table dimension, time dimension, and promotion dimension. Right. So why it is called a star schema? Because it is constructed in such a way that it looks like a star. That's why it is called a star schema. Right. So there's no even difference between मतलब इतना important नहीं है, but you should know कि you design your facts and dimension table in such a way that Your fact table is the central, it always in the center, and dimension are surrounded by that. Now that you have developed a fair understanding of a database, you might be wondering how data warehouse and database differ from each other, right? So for that reason, we are understanding this. So that is most familiar database that we are all used to. So probably the transactional database is the most familiar database that we are really used to, and we know we can relate it to. That's what you mean when you say the difference between a data warehouse and database. So I'm assuming when you say database, you mean this kind of a transactional database, right? Which means any database that helps me carry out, say, automation of activities. If it is banking system, I can be using my card in the ATM machine. So that is also transaction that requires a transactional database. ATM transaction. That is also transactional. That requires a transactional database, which means transactional database are those database which help carry no users carry out their day-to-day business transactions, whatever that might be, or whatever that domain might be. Now let us now try to contract it with the data warehouse. So the data warehouse is intended for completely different purpose. The transactional database is intended for carrying out business transactions. Transactional database is intended to carry out business transactions, whereas a data warehouse is also a database. It is intended to carry out analysis, analytics, and decision making. So we can distinguish both of them from multiple dimensions. So let us try to distinguish it from the user's perspective. Yes, Supriya.
What is the difference between analysis and analytics?
Analysis and analytics. Okay. A careful study of something to learn about its part, what they do, how they are related to each other. It's also an explanation of the nature and meaning of something. Analysis is to investigate why something happened in the past. For example, analyzing the variance between a company's budget and actual figure. But what is analytics is systematic computational analysis of data or statistics. It is used to discover, interpret, and communicate meaningful patterns in the data. Analytics is used to explore potential future outcomes by applying logical and computational reason to past and current data. So analysis is done on the past data, but analytics is something that is used to explore potential future outcomes by applying logical and computational reason. Right? Is it clear now?
Yes.
The analysis deals with events that have already happened, while analytics takes on the past and current data, and is primarily forward-looking analytics. Yeah. So we can distinguish both of them from multiple dimensions. Let us try to distinguish from the user's perspective. User's perspective. Who are the different types of users who use transactional database, data warehouse database, and transactional database? Is used by end users like you and me who want to carry out some business transaction online. So on the other hand, data warehouse database is used by decision makers by managers. So typically, the CEO, CXO, or even uh, someone who is related or associated with decision making. In fact, those kind of decisions are systems where you used to be called as DSS, which is known as Decision Support System, as opposed to MIS or Management Information System or just Information System. So to understand the difference between the transactional database and data warehouse database, what we'll do is we'll understand its purpose first. So it is used to perform business understanding, first part, or business transactions. Second part is user, end users, or for business transactions. The data warehouse is used to conduct analysis and decision making. Then managers, CEOs, and CXOs for decision making. Then we have a technology side. Yeah. So the first distinction is in terms of users who are using it. If you want to go a bit deeper, we can also now begin to distinguish on the technical side. So let me tell about the similarities in both the cases. You have some kind of server ecosystem that's there to support the system. So if it's a decision support system or an analytic system in a data warehouse, or if it is transactional database, in both cases there are database. So the similarity is there, right? In both cases there are some database management system software that is running for managing the data. In terms of technology, there are additional moving parts when it comes to the data warehouse. If you recall the discussion we had on database architecture, largely, right, one very significant component of a data warehouse architecture is the ETL process, which is known as extract, transform, and load. Because as part of the definition of the data warehouse itself, one of the key terms is that it is integrated. What we mean by integrated is we expect the data warehouse to contain data from multiple sources, from multiple departments, from multiple database. So in order to make that happen, ETL is very significant element of a data warehouse which finds no place in the transactional database. In the transactional database, you have the DBMS, you have other side server side application to no APIs, and application servers, no JBoss server, and so on. And the technology stack is quite different when it comes to transactional database compared to data warehouse database, right? So the key difference even at the server level is that there is no ETL present in data warehouse. So first point I can add it as no ETL process in transactional database. Second point is DBMS, and third point is server or service side application or API. First is ETL process, which is extract, transform, and load process. So we have a data warehouse which is known as integrated, multiple source. We have multiple departments, and we have multiple databases, right? So the kind of technologies that are used are known as web server and browsers for interaction, mobile phones, and interfaces with payment gateways, payment systems. So a lot of transactional front ends are there in my transactional database. For the data warehouse database, the front end is essentially only what you be known as the BI tools or business intelligence tool, which means that it contains a lot of reporting tools. So you will have tools like Cognos that are running. You have tools like Tableau. You will have many reporting front end infrastructure, because the intention of a data warehouse database is not to support business transaction. The intention is to support analysis. So we have BI tools like reporting tools which add value to the information that is stored in a data warehouse database. So I can do lots of analysis. I can drill down, I can do roll up. Those kind of operation can be done on data warehouse database using business intelligence front end. Whereas in transactional database, we generally don't have any such front ends. Lot of interactive reporting is generally not available on transactional database. At the most you may be having some so-called canned report. You may be having some so-called canned reports. I mean, it can generate any inventory report of any of my products in my shelf, for example. So beyond that, there is not much of analytics that is going on. So even the technology stack is kind of different from a data warehouse database versus a transactional database. I want to reiterate, in both the cases, we should call them as databases. Only say, don't ever ask the question, what is the difference between data warehouse and database? In the question to ask is the difference between a transactional database and data warehouse database, right? So front end technology side, we can add this point that it has web servers, it has web server. Second is it has browsers for interaction. Third is it has mobile phones. And last but not the least is interface with payment gateways and payment systems. Then here also you guys have BI tools, that is business intelligence tools like Cognos, Tableau, and C's reporting front end infrastructures.
विपुल और कॉग्निस एप्लीकेशन है क्या?
It's not needed. IBM Cognos, you don't have to worry about it. Cognos we use, IBM Cognos is used. It's something like your Tableau and Power BI,
Okay.
but nobody uses it widely. Earlier they used to explore this, but nowadays Power BI and Tableau is widely used.
Yes, I never heard this one.
It's same like your Tableau Power BI. All right, so let us stop here for the day. I'll just save this. If you have any questions, you can ask. All right. Let's stop here for the day. Thank you. Bye.
Thank you, sir.